This is Lecture 6, Part 1, Chi-square test. By the end of this lecture, you should be able to write null and alternative hypotheses, construct a cross-tabulation between two variables, interpret a cross-tabulation between two variables, understand how a chi-square test determines the relationship between two variables, conduct a chi-square test and interpret the results from a chi-square test, and know when to use a cross-tabulation and chi-square test to assess the relationship between two variables. A cross-tabulation table allows you to use simple tables to analyze the statistical relationship between two variables. It is most useful when you have nominal and ordinal level dependent and independent variables. Recall that both nominal and ordinal level variables separate observations in your dataset into categories. For nominal level variables, those categories have no order, and for ordinal level variables, the categories do have order. Consider the following hypothesis. Women are more likely than men to identify as Democrats. Now imagine I wanted to determine whether there was in fact a real-world relationship between gender and party identification. I could conduct a survey and ask respondents their gender and their party identification. Here is a hypothetical dataset that could come from such a survey. There are 10 hypothetical respondents, 4 females and 6 males, and 5 Democrats and 5 Republicans. So were women in this survey more likely to identify as Democrats than men were? We could use a cross-tabulation table to find out. To set up a cross-tabulation table, the first thing you need to do is write the dependent variable name in the first column heading. Then you write the categories of the dependent variable in the rows below that. Then you add a total row at the bottom. Then you add the independent variable category names in the subsequent column headings. And last, you add a total column at the end. So in our example, since party identification was the dependent variable, we write party identification in the first column heading. Then we add Democrat and Republican labels in the rows underneath, as they are the category names for the dependent variable. And then we add a total row at the bottom. Next, since our independent variable was gender, we add the labels male and female to the subsequent column headings, as they are the categories of the independent variable. Then we add a total column at the end. After we set up our cross-tabulation table, we have to count how many cases from our data set fit the criteria for each cell. So for example, as you can see here, we have male Democrats. We would go to our data set and look for how many cases fit this criteria. So as you can see, we have 2 male Democrats. So in the male Democrat cell, I wrote the number 2 in parentheses here. In the second cell, we have female Democrats. We would go back to the data set and look for cases that fit this criteria. So we have 1, 2, 3 female Democrats. Hence, in the female Democrat cell, I wrote the number 3 in the parentheses here. We would complete this process for each cell. After you input the correct information in each cell, you then have to calculate column totals and row totals. The first column total is calculated by summing all the observations in that column. So in this case, 2 plus 4 is 6. In the second column, 3 plus 1 is 4. Then you go to the last column and calculate the row totals. So in the first row, 2 plus 3 is 5, and in the second row, 4 plus 1 is 5. And then last, you calculate the total number of observations So 5 plus 5 is 10, or alternatively, 6 plus 4 is 10. After you calculate the total number of cases in each cell, you have to calculate cell percentages based on the column totals. The cell percentage is calculated by taking the total number of observations in a cell, dividing that number by the total number of observations in the cell's column, and then multiplying that value by 100. So in this first example here, the male Democrat cell would be 2 divided by 6 times 100, which is 33.3. And the male Republican cell would be 4 divided by 6 times 100, which equals 66.67. And the last cell would be 6 divided by 6 times 100, which should just be 100%. You continue this process for the subsequent columns. And this is what your cross-tabulation table should look like in the end. In order to interpret the cross-tabulation table, you must compare cases across the same value of the dependent variable. Many students forget how to do this, so it is really important that you remember this. Otherwise, you will not know how to interpret your cross-tabulation. In this case, I would compare males and females in the Democrat row only. 75% of women supported Democrats, whereas only 33.33% of men supported Democrats. It does seem as though women are more likely than men to support Democrats. So we can conclude that women are more likely than men to be Democrats. In the cross-tabulation table, 75% of women were Democrats, while only 33.3% of men were Democrats. When I ask you to interpret a cross-tabulation table, I want you to follow this format. Make a conclusion, and then use the information from the tables to support your conclusion. We can repeat this process for other values of the dependent variable. In this case, I would compare males and females in the Republican row only. 66.67% of men were Republicans, while only 25% of women were Republicans. So we can conclude that men are more likely than women to be Republicans. In the cross-tabulation table, 66.67% of men were Republicans, while only 25% of women were Republicans.